Hey everyone, we're looking to hire a part-time communications manager to join the Epicenter team. You can get more information about that position at epicenter.tv/apply. So if you're interested in learning more about that, if think you have what it takes, go to that website and you'll find the job description and the instructions on how to apply for our communications manager position. Thanks. This episode of Epicenter is brought to you by Jax. Jax is the user-friendly wallet that works across all your devices and handles both Bitcoin and Ether. Go to jaxx.io and embrace the future of cryptocurrency wallets. And by the Ledger Nano S, the hardware wallet which sets the new standard in security and usability. Get it today at ledgerwallet.com and use the offer code EPICENTER to get 10% off your order. Hi, welcome to Epicenter, the show which talks about the technologies, projects, and startups driving decentralization and the global blockchain revolution. My name is Sebastian Couture.
And my name is Brian Fabian Crane. We're here today with Tom Ding and Dominic Williams. They are CEO and president / co-founders of String Labs. Now, Tom has actually been a guest on this show before, a long time ago. At the time, he was the CEO of a company called Coinify, which were sort of doing managing crowd sales back then, quite ahead of its time, I think. Now this has boomed a lot. So, and Dominic, we've been wanting to get on for a long time as well. He was working on stable coin concepts already, I guess also maybe 2 years ago or something like that. So thanks so much for coming on, guys.
Pleasure.
Good to be here.
So would you mind running us through, maybe both of you guys, how did you first get involved in the blockchain cryptocurrency space, and what was the journey to get to String Labs?
So I got into Bitcoin probably about late 2013. Bitcoin price was, or actually early 2013, Bitcoin price was like $80 something. Ignored that for a while and then saw the white paper like a lot of people and then kind of realized there's something into it. So my first journey into it was looking from the perspective of what are the interesting kind of crowdfunding kind of a model that can revolutionize that traditional crowdfunding model. So that was a bit of time at Coinify. And then also did another more interesting kind of side project, Blockchain University, which at the time started kind of a first in-person developer education program. It's really kind of a nonprofit community program, but it really helped bootstrap, I think, some of the community and awareness around blockchain technology. Had like 300 or 400 graduates out of that program. A lot of people out of that program still pretty active, I think, in the industry. But later on, I think what gets for me more interesting was how could the new kind of decentralized technology could change some of the very fundamental way of how business can be done. And that kind of lead a lot of a discussion later on with Dominic. And I think it's really interesting to me was starting with things like mirror assets. How could you create digital assets in a decentralized fashion, completely decentralized fashion? That kind of started the journey with String Labs. We started with mirror assets and move on later on to the DFINITY project, which is a new decentralized network that we're going to talk about today.
Well, I'm a long-time sort of hacker entrepreneur with interests in distributed computing. I actually first came across some of the ideas behind Bitcoin in a paper called B-Money by Wei Dai in I think it was 1998 or 1999, and I was using his Crypto++ library to create a certificate system. And I read the paper, thought it was very interesting, was very busy with an online storage startup actually back then. And then sort of 2011, I launched this kids game, which grew enormously. It ended up with 3 million users. And through that, I did a lot of work on distributed systems, scalable application servers. I worked with a database called Cassandra. In fact, which is a scalable database used by Netflix. Now we had the first complex production sort of implementation of that, and I contributed various code to it. So I mean, it was during that time, I was thinking. I mean, Cassandra in some ways is a decentralized database, anyways, right? You add these servers to whenever you want to increase the computational capacity and the storage capacity of your cluster, you just add a new server to the database's gossip network. So I was already thinking, how far can this be taken? And then, Bitcoin sort of crashed its way back into the common consciousness in a major way in April 2013. And I think partly because I was primed from Wei Dai's thing, partly because I was, into distributed systems in a big way, I was looking for something else to do, and I just very quickly became completely consumed by decentralized protocols and trading crypto tokens, and it just took over my life, and here I am today.
It's fascinating that you mentioned Wei Dai's B money. A lot of people don't really, think that there were any decentralized distributed currencies before Bitcoin, but this one is sort of a weird predecessor that actually Satoshi referenced when creating Bitcoin that board a lot of the same principles as Bitcoin. So I encourage anyone who's interested in that to go read up about B money. So let's talk about String Labs then. Tell us about the company and what you guys are trying to achieve.
Yeah, so I guess we position String Labs really as a kind of incubator and kind of rocket launcher, if you will, for many different decentralized opportunity. If you think about a layer of opportunity within the decentralized space, there's obviously the very fundamental problems we're trying to address, like scalability, privacy, and et cetera, business adaptations, the very network layer. On top of that, you have many common needs that a lot of businesses and decentralized startups or constructs would need. For example, stable currency, identities, arbitration, et cetera, et cetera. I think we kind of position String Labs as a general incubator and investors and developer ourselves of creating both in-house and external projects to launch projects at these different layers, which is quite a unique model. It's a venture-backed, but most of the projects we create, when it gets to certain maturity, once it pushed to a certain stage, they will have their own independent existence, and which is one of the very nice thing about decentralized projects. They are independent protocols. They're not necessarily controlled by any certain organizations. So we're kind of uniquely benefiting from this venture backing with stable financial stability, but also the ability to create neutral and independent protocols.
I'm curious that so you say you're a venture-backed company, and that's definitely one position to have as opposed to relying on a crowd sale. Why do you think so many other companies or other projects in this space are going towards the crowd sale route rather than going in the direction that you've taken, which is to raise capital?
We kind of, by the way, prefer the term donation, which kind of more precisely reflect the nature of the process. But anyway, I think the difference, I guess, part of that, I think we're quite lucky. We have some really good visionary backers, including like IDG, Amino Capital, Fambusha Capital, which is, I think, was the first $50 million dedicated fund from the Manchang Group, probably the first in the world. But I think with these kind of venture backing, it creates a more stable structure. Because in general, there's a kind of a fallacy or concern of you rushing too quickly into the donation phase. Say, hey, everyone, please donate before the project even reaches a certain stage.
I mean, donations does not sound at all like a good description of what's going on with that.
Well, I think at the moment in the market, it's probably not true. But, the right way to look at this is that a foundation... Well, look, I mean, the whole point about a decentralized network is that it doesn't depend upon some organization or individual, right? So once you've created that network, it's fundamentally dependent on a decentralized community of independent miners, right? So, it's possible to create a not-for-profit sort of tax-exempt foundation, right, in somewhere like Zug, Switzerland. And it's possible for that thing to collect donations, right? And then take those donations to develop the technology. And it's also possible for that foundation to recommend, when the technology is ready, that people who've donated to the foundation and otherwise contributed to the birth of the project allocated, some reward in the Genesis block. But actually, the foundation, it's not even in the power of the foundation to issue tokens to people, because all it can do is recommend something to the miners, right? It's ultimately, whatever Genesis block a foundation recommends, it's ultimately up to the miners to adopt the recommendation and make that real.
I mean, I can see why one phrases that, of course, to avoid some legal liabilities and stuff like that, but it does not at all sound like an accurate description, or it doesn't at all sound like it describes the motivations of both the people who donate/invest in these projects, nor the people creating them.
That's true.
I mean, they're
yeah,
giving money because of the expectation of a financial return, which is not a donation.
Well, I mean, I think, people will take different approaches, and, I think we'll probably exemplify a slightly different approach. I think tokens should be designed very much to enable participation. And, I think there are some kind of slightly shady things that go on in the industry, frankly, at the moment. And, we would not want to follow that path, or would encourage other people not to follow that path. I think it's true that there are a lot of people who would like to, make money or gain resources through launching these systems, and that's fine, and that's fair enough. But, the exact process by which that is done is very, very important. And, we shouldn't be encouraging FOMO-based pump and dump speculative kind of shitcoin ventures, right?
Yeah, totally. Let's come back to DFINITY. So, what are you trying to accomplish here with DFINITY? What's the project going to look like, and what kind of difference is it going to make in the blockchain space?
So DFINITY is, positioned as an extension to the Ethereum ecosystem that's governed using a kind of decentralized intelligence called the blockchain nervous system. And it introduces a lot of new crypto and decentralized network protocols that have been sort of in the works since 2014. Firstly with a project called Pebble, and then later with DFINITY. And, these protocols are very interesting. They introduce some completely new properties with specific regards to scalability. We want to create an infinite decentralized cloud that can eventually host, big public infrastructures like Twitter, Gmail, Uber, even web search, and as well as, financial exchanges and various other business applications. All of the crypto and the protocols, we're deliberately not patenting anything. It's all open source, so it could be backported into Ethereum. So the main distinction ultimately is, governed versus ungoverned.
So you mentioned something like a decentralized Twitter or some of those decentralized search. Now, my understanding, I guess, is with Ethereum, I'm not sure if that's really an objective to get to that kind of level, but if it's more the objective to have, sort of this core logic of distributed applications in there and a lot of other things take place elsewhere. So is that a differentiation as well, that you guys are trying to put sort of entire full applications on the chain, whereas Ethereum applications might be more of a bit of a hybrid?
So yeah, I think that probably is a distinguishing factor currently. I'm not sure if it'll stay a distinguishing factor. So DFINITY was, begun with the specific aim of being able to host that kind of stuff and creating this, infinite decentralized cloud. I think because of the history of Ethereum, there's a sort of concept out there that it should only be used for high value fiduciary applications, and that wherever necessary, wherever it needs to, be linked to storage, for example, some large file, the large file should reside on IPFS. that we certainly, we don't share that vision right now. We want to produce an infinite decentralized cloud which can store data and perform any number of computations as necessary. And the research work was begun with the basic requirement that all designs worked on a network of 1 million plus computers or clients, because if you look at the Google Cloud or the Microsoft Cloud, for example, in both cases they have more than 1 million servers. So we wanted to make sure that we could work with any number of computers, and furthermore, as you add more computation power in the form of new mining clients, that the overall storage capacity and computational capacity of the network increased.
Well, that's interesting. There's other projects. Recently, we had on Greg Meredith of Cinero, and that project also seems to be taking a similar approach where all of the components of the tech stack are built into the same architecture. When you look at the way applications, so traditional applications are built today, all of the components, whether they be storage, logic, and database, are typically not part of the same stack. You may have sort of recommended stacks or stacks that become adopted by the community, like for instance PHP, MySQL, or Node.js, MongoDB, that sort of thing. And then storage, can be decentralized, or sorry, can be distributed on like some cloud architecture or something like that. It seems to be contrary to the way that traditional applications are built, in a way that we have added, the best interoperability as possible. Can you go into detail or sort of explain the design rationale behind why DFINITY is chosen to build everything into one core system? Because I personally see that as some sort of a weakness.
Yeah, so
because
I understand the question. Yeah, so it's first of all, yeah, we're very different to Scenario, and Scenario, has. I think it's, I'd like to hear more about how exactly they're going to create a scalable system. And secondly, they've also got this kind of stack of, social networking layers and things like that, which are derived from a system that's certainly not a virtual machine. So, first of all, DFINITY is just trying to produce a tamper-proof virtual machine, right? A scalable tamper-proof virtual machine, but, a tamper-proof virtual machine. We're not producing directly, at least, any kind of foundational layers on top of that for people. The DFINITY project is just focused on the production of this virtual machine. So, stepping back for a moment and asking, what does that mean? Well, if you Bitcoin, Satoshi's invention was actually, from my perspective, the introduction of something called a stateful decentralized protocol, right? So BitTorrent is a decentralized protocol, right? But it doesn't remember state. So, if I send a file to you over BitTorrent, it doesn't make any difference to everyone else. Bitcoin was different because, it produces this virtual ledger, right? And if I put a freely spendable Bitcoin onto that virtual ledger, and then, Sebastian, you spend that Bitcoin on the virtual ledger, well, Tom now can't spend that Bitcoin, right? So that means that the state of that virtual ledger has been remembered, which is why we call it a stateful decentralized protocol. Now, Bitcoin produced a virtual ledger. Ethereum moved the game on and produced a virtual machine, a virtual computer, if you like, a tamper-proof virtual computer. And this was a very interesting thing because we can install software on it that runs exactly as you'd expect, and if you want, autonomously and independently from humans, which provides a lot of very interesting properties. So, DFINITY is a stateful decentralized protocol that produces a tamper-proof virtual machine, but it introduces the extra attribute that the virtual machine is scalable.
Let's take a short break to talk about Jax. Jax is a multi-coin wallet created by the people at Decentral. Now, in the past, if you had a whole bunch of cryptocurrencies, it was a pain to handle them. You either had to leave them on an exchange, which was insecure, or you had to have all these different wallets, which was a hassle. Fortunately, now with Jax, those medieval days of darkness, misery, and suffering are over. Jax supports multiple cryptocurrencies and new ones are being added. But it's not just storing cryptocurrencies you can do with Jax, but you can also exchange them directly from within inside the wallet thanks to their Shapeshift integration.
And since there's only one seed, Jax makes it super easy to back up and sync to your other devices. Jax works with Windows, macOS, Linux, Android, iOS, and has browser extensions for Firefox and Chrome. So go to jax.io, that's jax.io, to download the wallet and get started today. We'd like to thank Jax for their support of Epicenter.
Now, you mentioned infinitely scalable. Of course, that is sort of this, holy grail in the whole blockchain space. So can you talk about what does that look like? How does DFINITY accomplish that?
There are many dimensions to the design of DFINITY, and we introduce a bunch of principles, and many of them traditional computer science principles into the design. So we like to separate concerns. So our designs typically separate Sybil resistance, consensus, validation, storage, so that you can, and we're trying to couple them so they can be addressed in an optimal way. But at the core of DFINITY, I suppose, is an observation about the importance of randomness, that all decentralized networks and also advanced high-level systems ultimately depend on incorruptible, unmanipulable, unpredictable source of randomness. And we introduced this thing called threshold relay, which is the ultimate incarnation of that. So you could look at Bitcoin, for example, and proof of work and say, really, proof of work, casting aside the Sybil resistance requirements for a moment, is really a random number generator. You have this big, huge network of mining clients, and they all want to produce blocks. So Bitcoin has them race to solve a current puzzle, which can only be solved by brute force, with solutions appearing in a Poisson distribution. And whoever solves the current puzzle first, is assigned as a temporary leader, and they can distribute a block to be appended to the current chain. Now, there are some issues with that with respect to designing high-performance networks. In particular, the Poisson distribution, whereby you don't know how long it'll take for a block to be produced, is very problematic. So if you ever look at the block explorers for Bitcoin, you'll see that sometimes you get a new block 20 seconds after the previous block, and other times it'll take hours, right? That's the Poisson distribution. It takes a random amount of time to produce a block. So, that's quite a expensive and difficult way to produce randomness. We apply cryptography in a novel way to produce randomness. And not only can this randomness only be produced on the agreement of large parts of the network, but the randomness that is produced is unforkable. It's unmanipulable and unpredictable. And using the properties of this randomness, we can do a variety of things. There's actually a number of different high-level chain consensus protocols or chain agreement protocols that can be used. But perhaps more importantly for us, we can hang scalable validation layers off the random sequence of values. So we have a technique called validation towers, and these are arranged into a thing called a validation tree, which is a bit like, does for validation what a Merkle tree does, although the individual nodes can behave asynchronous, can operate at different speeds over the network. And this makes it possible for us to create a single digest of all the state stored, for example, on shards across the network. And that system only really works if you have this incorruptible, unmanipulable, unpredictable source of randomness.
So I watched this talk, and this is a bit of a tangent on the topic, but I think it's really interesting. I watched this talk by Timo Henke, who's one of the people that works with you at String Labs, who describes sort of different ways that we can generate randomness, and specifically how we can generate randomness in a decentralized way. And one of the things that he mentions, and I'd like to get your thoughts on this, is, and specifically, as you pointed out, is that the proof of work system algorithm is meant to generate some sort of randomness. And if we had this decentralized true random number generator, is there any potential there to develop new types of consensus models that can work in a decentralized way, sort of as proof of work does, but doesn't have some of the flaws of proof of work and proof of stake?
Absolutely. So one way to see the importance of randomness is to look at Bitcoin and to imagine conversely that it couldn't produce randomness. So we'd see some problems emerging straight away. Firstly, if you knew in advance who was going to mine the next block, you'd be able to DOS that target, right? If you could, obviously mining has become very centralized and it's a bunch of pools, but let's just imagine, in fact, it was more decentralized as it was meant to be, and that somehow you'd stripped the IP addresses of the important miners out of the P2P network. If you knew which miner was going to mine each block in advance, you might be able to DOS them. If there were higher level systems depending on that, and you knew in advance who was going to mine a block, well, if an adversary controlled a sequence of blocks, he might be able to perform some manipulation on financial markets or something like that by censorship or some other strategy. In addition to that, it'd be very difficult to decide how to fairly distribute the mining amongst the participants. And in fact, even worse, if it was manipulable, one miner might be able to, and this is the kind of problem that, would stop something like NXT working. One miner would be able to choose what transactions to put into a block, say, to, modify the random value that it created, and if this influenced who was going to be the next miner to produce the next block, well, you might be able to an adversary might be able to take control of mining and just influence the path taken so that it was always his own, clients that were creating blocks. So it's very important that it's not possible to manipulate randomness. And, in the case of Bitcoin, you have to solve these puzzles. So pretty much the only way you can do that is if you have the mining power. And you can only solve those puzzles by having this mining machinery whir away, and it's the probability that you'll solve the puzzle first is proportional or approximately proportional to the amount of mining power that you have deployed. So, randomness is absolutely fundamental to decentralized networking, and as it happens, also as it turns out, high-level systems too. So, with the threshold relay system, we strengthen a lot of properties, while also removing the need to produce random numbers in a Poisson distribution. And because this randomness is deterministic and unforkable and unmanipulable and so on, it actually becomes relatively straightforward to create consensus protocols on top of it. Just a quick thing, I'll just say something quickly, which is that I'll talk about consensus protocols, but strictly speaking, it's a common misunderstanding. The word consensus actually is applied to traditional distributed computing protocols, which allow all the participants to decide a result and then move on. Blockchains actually are probabilistic, which is slightly different, and they're kind of eventually consistent. So something like Bitcoin is better described as something like a Byzantine fault-tolerant, eventually consistent log, right? And an agreement is kind of iterative, and it becomes stronger over time. So it's more of a kind of an agreement protocol than a consensus protocol. But I'll use the word consensus from now on.
So you mentioned mining. Now, again, people understand Bitcoin mining. In DFINITY, does that look? What's the sort of connection here? Would that also mean I'm gonna be able to spin up my machine, and if I control 1% of the mining power, I'm gonna sort of get 1% of the reward? Is there a block reward, or get to mine 1% of the block? Is there a similar thing?
It's not too dissimilar. I mean, in DFINITY, we require mining clients firstly to create a mining identity. And very approximately, we look at these identities as representing some fixed amount of computational resource. Okay, so you create a mining identity by making a deposit of definities. So in that sense, it's a bit like proof of stake, but because we imagine each identity, or we require each identity to have some amount of computational resource, the deposits you make to create a mining identity are always the same, right? So, if you look at something like Casper, people make something akin to a mining identity by depositing stake, and that stake can be of varying sizes. So, a big whale could come along and create an enormous, ID that would mine an enormous proportion of the blocks. So in DFINITY, first of all, each mining identity, which is like a public key, is expected to supply a certain amount of computational resource, and consequently the deposit required to create an identity is the same at any one time. It varies a bit set on this governance system, but that's the first thing. Then once that mining identity has been joined to the network and begins to participate in mining, there's a thing called a unique state copy ID, which is another new bit of crypto we're introducing, which requires the mining identity to constantly report on a uniquely encrypted copy of state that it manages. And this is done in such a way that we can be sure that each identity has this unique copy of the state, because we need to manage replication, okay? And it's done in such a way that we can be sure that the state that it's reporting on, okay, isn't just coming from some centralized state pool, right? There isn't just some like big, mega server in the sky that is actually maintaining this state, and the whoever controls the mining identity is just, forwarding queries to it. So it's a kind of combination. So you could look at that as a bit like unique state copies are a bit like proof of performance. So it's a kind of funny hybrid, really, in that sense. The identities are created by depositing some stake in DFINITYs, but the amount of stake that you deposit is always the same, because the responsibilities of that identity will be the same as the responsibilities of the other identities in respect to computational resource. And then there's this thing called unique state copy IDs, which kind of holds the mining identity to its part of the bargain and forces it to constantly prove that it's maintained this unique copy of the state.
You guys mentioned Ethereum before, and to me it sounds like this is a fully alternative protocol to Ethereum, going to be an alternative public blockchain that sounds like it's going to have some powerful benefits.
Today's magic word is neuron. Neuron. Head over to letstalkbitcoin.com to sign in, enter the magic word, and claim your part of the listener reward.
Can you explain, though, because you've also talked about how it's going to be complementary and sort of an extension, like how is this not just a competition and sort of an attempt to create, the follow-on to Ethereum, just as Ethereum tried to create the successor to Bitcoin in a way?
So I think the first thing to remember is that, we don't believe in patents, and it's an open source project. So all of our crypto and protocols could potentially be backported into Ethereum. So, and in fact, we want to maintain the maximum level of compatibility possible with Ethereum. So for example, our EVM is slightly different, but for the most part, it's the same. And, rather than going off and trying to create our own virtual machine, we're just going to, fund and assist Ethereum projects. So, potentially Ethereum can take all of our technology. The main difference is governance. So, in terms of market position, there's a few things actually. I think it's probably true that we are more obsessed about scalability than Ethereum. There are some things that come with that. Arguably, you could say we favor consistency slightly more than Ethereum does, and Ethereum might favor availability slightly more than we do. So there are some differences in vision, I think, at the network level. But the main, distinguishing factor is this governance and some other features that provide interoperability between private and public chains, which reflects the needs of some of our partners. So, we see ourselves extending Ethereum and providing, and addressing a different segment of the market. There are people out there that want the code to be law. There are lots of benefits to the code as law approach, but there are also people out there that want a governed system, that can reverse hacks like the DAO and things like that more easily. Specifically, the business community really wants that because, if you're a big company and you want to put, a large amount of money into tokens in a virtual computer and maybe, build systems on that virtual computer that become crucial to your organization, right? Well, you don't want to wake up one day and find out that your developer has made a mistake when they've designed the software or the smart contracts, and some hacker has corrupted it and put it into an unrecoverable state, and there's nothing you can do about it, or even worse, he's stolen tens of millions of dollars worth of tokens, and the only answer is that you can use the block explorer to follow them around the blockchain, right? So, a lot of businesses, will happily make the code as law contingent upon some higher level governance AI. And, for them, that's a better alternative. So I think, it's not so much about producing a better Ethereum as extending the Ethereum ecosystem. And so people have a choice. Some people who want the code as law systems can go with Ethereum, and people who want governed systems can go with DFINITY.
Yeah, so I'm really happy you bring this topic up. Governance is something that we've been asking people about pretty much any time somebody comes on with a project, because I think at this point it's abundantly clear that this is a massive need. Even if you look at Bitcoin, right, there's a huge disagreement about what direction it should go in, and there's no way of resolving those agreements. And then again, with Ethereum, we've seen the same thing. And it seems like a lot of the new protocols that are coming out are taking this seriously and trying to do things in this direction. So I'm very curious, can you run us through what the mechanics of the DFINITY governance system look like?
So, we've got this thing called the blockchain nervous system, and the blockchain nervous system has privileged access to the virtual machine. So inside the virtual machine, you've got these things called opcodes, which are a bit like assembly instructions, right? So when you're coding in C, that compiles down to a bunch of assembly instructions that execute, the CPU executes, right? And on Ethereum, you have a language like Solidity, and that compiles down to these opcodes, which run directly on the EVM, the Ethereum virtual machine. So we've extended the Ethereum virtual machine to add some new privileged instructions, which can do things like freeze contracts, redistribute tokens, even run arbitrary code to reorganize things. And the blockchain nervous system is the only, system on the platform that has access to these opcodes. Otherwise, it'd be chaos, obviously. And so it's like a sort of super user on Linux or something, right? It can, freeze bad contracts. It can redistribute tokens. It can run arbitrary code to reorganize things that also, have access to those special opcodes. And the system runs, like as follows. People can submit proposals to the blockchain nervous system. You have to pay a fee in DFINITYs to stop it being spammed. There are different kinds of proposals. Some are very technical, such as let's upgrade the protocol to this, and others are more related to governance. For example, how much should it cost right now? How much should be deposited to create a mining identity, given the current value of DFINITYs, for example? And decisions on proposals are made using a distributed version of liquid democracy. Okay, so individuals can create neurons. Okay, you create a neuron by depositing DFINITYs. It's a bit like proof of stake, and you can only get those DFINITYs back by dissolving the neuron, which takes 3 months. So you have a big incentive to make sure that the blockchain nervous system doesn't make stupid decisions, because your DFINITYs might fall in value, right? You can't get them out quickly. It takes 3 months to dissolve a neuron. Once you've created a neuron, you have to install some client software, which loosely you can think of it like sort of thought mining or something. You have to install some client software on your laptop or desktop or whatever it is. Configure it with the delegate key. And this client software behaves as follows. Firstly, you can configure it with a follow list, which is the addresses of other neurons that you follow on different topics. Okay? So let's imagine that a highly technical proposal comes into the blockchain nervous system in respect to upgrading the blockchain nervous system protocol. The client software running obviously on the edges of the network would detect this proposal and display it, okay, in the technical tab, and it would wait for a default amount of time to allow the controller of the neuron to vote on that proposal. Now, if it's a very technical proposal, it might be that only a small proportion of the people who have neurons would feel qualified to vote on the proposal. So after a default amount of time, the neuron client software will go to the follow list for technical topics, right? And it will say, right, has the first neuron identified by its address in the list voted? If so, follow. If not, back off. If it's backed off, after a short while, it will come back. Has either of the first 2 neurons in the follow list voted? Okay, the second neuron in the follow list has voted, so just follow the vote of that neuron, right? So, it's kind of asynchronous and non-deterministic, and eventually the blockchain nervous system, the sort of distributed brain, if you like, will cascade to a decision. Obviously, over time, the follow lists get better. For example, you might be particularly impressed by somebody on Reddit who happens to advertise the address of their neuron, and you might configure that address into your neuron's follow list, right? And the nice thing about the system is, obviously, on the one hand, it captures the expertise within the community, right? But on the other hand, nobody can know how these decisions are made. It's completely opaque, which is why we call it opaque liquid democracy. Because the follow lists exist on the edges of the network, right? And there's no way of capturing what those follow lists are. And this is very, very important because, for example, let's say, Tom was, the most, given this follow graph amongst the neurons on some topic, Tom was the most influential person in the community. Well, there's a number of problems. I mean, firstly, somebody might realize this and seek to kidnap Tom or extort him or influence him. Or more likely, if some controversial decision was made that upset a regulator, for example, somebody might try and sue him, or some government agency, might seek to, do something bad. But as it is, you can't see how the brain makes its decisions.
No, I love this. I think that's very exciting, and it's one of the liquid democracy, right? Maybe so people can relate to it a little bit in the existing political system, right? So today we kind of vote for somebody maybe to become a member of parliament, and then they just make whatever all the decisions as a kind of a delegate. And this, in a way, is almost a more fine-grained way of creating delegates, where you can say, foreign policy, I'm gonna follow this person. On this other policy, I'm gonna follow this other person. So I think that's very exciting. Now, one question, you call this an AI. Why an AI? It doesn't sound like, it's more like a existing democracy than an AI, it sounds like to me.
Well, to some extent, it's an easy way of explaining what it is, but there are some differences between normal liquid democracy and certainly major differences between the blockchain nervous system and traditional democracy. So, rather than just a simple delegate democracy, what we have is a sort of dynamic trust graph, I suppose, where I could follow you, you could follow Tom, and so on ad infinitum, right? And these there's a graph of follow relationships that is not only dynamic in the sense people can change it all the time, but the way that it comes to decisions is very much non-deterministic and dependent on timing and things like that. So the dynamism is important too, because the system improves its ability to make decisions over time as people update those follow relationships. So, it's not like a traditional piece of artificial intelligence like a neural network or a Bayesian classifier, but actually those things are completely different to a brain as well. So in some senses, we've got a kind of distributed wisdom of the crowds processed through, this very dynamic algorithmic system of neurons following each other. So, arguably, we've got more of a claim to be an artificial intelligence than a Bayesian classifier or a neural network.
Let's take a break to talk about the Ledger Nano S, the new flagship hardware wallet by Ledger. I'll let Ledger's CEO, Eric Larchevêque, tell you all about how simple the Nano S makes it to securely store all your private keys.
The Ledger Nano S is our latest generation hardware wallet. This is a multi-currency hardware wallet. It has a screen and buttons to manage everything on screen. You can generate a new seed, restore a seed, or set up your PIN on the device. Your seed will never be exposed to the host computer. On the Nano S, you have different apps. You have the Bitcoin app, you have the Ethereum app, and you have the FIDO U2F app for strong authentication, for instance, with Google, Dropbox, or GitHub. You can manage your cryptocurrencies with the Ledger Wallet Bitcoin Chrome app or the Ledger Wallet Ethereum Chrome app. With the Nano S, all your Bitcoin and Ethereum addresses are derived from one unique seed. With one seed, you can have in the same time Bitcoin, Ethereum Classic balances, and also, if you restore your seed, you will also recover all the keys associated to other apps such as FIDO U2F, SSH, GPG. So it's very simple, just one seed and multiple applications.
The Nano S sets the new standard in hardware wallet security and usability. You can get yours today at ledgerwallet.com. And when you do, be sure to use the offer code EPICENTER to get 10% off your first order. We'd like to thank Ledger for their support of Epicenter. So let's dive into the economics of DFINITY, and specifically with regards to the neurons. Talk about the different tokens that will be part of DFINITY.
there's a base token, which is DFINITY, and they can be used as fuel for computation, as Ether is in Ethereum. They can be used as deposits to create neurons. And by the way, there's like a sort of thought mining reward for neurons. And you receive this discounted by the proportion of proposals you didn't vote on. So, you would get a pro rata reward for your neuron, depending on how many definitors you deposited into it. And the voting power of the neuron obviously will be proportional to the definitors too. And if you miss half the votes, then you only get half the thought mining reward you'd otherwise get. That's the second use. And the third use is you can create a mining identity. So, definitors are best thought of as participation tokens. You can, the most, I suppose, an end user would use them just to pay for computation, but they also play crucial roles in helping the network function, either through its ability to make decisions, upgrade itself, reverse, mitigate misuse, or through, people being able to add new computing resources to the network to make it, give it more capacity.
So talk about how these tokens will be distributed, or are they mined? What are the sort of monetary characteristics of DFINITY tokens?
So we've got two kinds of mining. One is the thought mining. So if people who hold neurons will be issued new definitors, and people that are mining the network in the traditional sense, by adding computational resource, will receive definitors too. So you've got three different uses. Fuel as computation, creating blockchain nervous system neurons that enable you to participate in governance in a form of thought mining that can also earn you new definitors, and mining the network in the traditional sense by adding extra computational resource, which again earns you more definitors.
Yeah, so I just want to, I think we talk about a scalability point, the technology itself. We talk about the nervous system. I think another thing worth mentioning is the private-public integration. So the one way we design, I think, DFINITY very differently from many of the other kind of blockchain companies is we don't necessarily see private chain or public chain as one way against the other. People don't have to make a hard choice. Am I going to do complete private chain and be isolated and siloed from the rest of the public services, or am I going to complete public chain or exposing all my internal business internals? Now they can have a hybrid. We see a very similar paradigm to the internet. When you have the internet, you have the LAN as well. You don't lose your LAN, right? You still maintain your VPN or LAN, but you use the internet as a common meeting point. You use common protocols like HTTP, email, Twitter, whatever, as a common meeting point for these services. We see a very similar paradigm emerging for the mass adoption of blockchain or trusted computing, is that there will be lots of common services, identities, arbitration, etc. These are the basic building blocks. And especially when we're talking about a more complex system like stable currency. It's not like every single company which wanted to use adopt blockchain has to build their own stable currency. They would much rather prefer using an existing solution. For example, the FI project we're working on, or it could be some kind of common bank coin, color coin they'd like to adopt, and they can just reuse that service. And DFINITY provide a way to integrate the two. So you can have a private DFINITY instance or a consortium DFINITY instance that in your smart contract, you have a little declaration that allows you to call into the public DFINITY service. So all the different private chains can connect to each other and use common blocks. I think that's kind of worth mentioning in changing how way people think about it.
I'm starting to get a better idea of how this works then. So what you're describing is services that would be built on the public chain, and you mentioned a few. So like you could have an identity system, you could have a stable currency, you may have other services, and on your private chains that you deploy with permissioned known nodes, you simply include sort of as you would in a program, like in a regular application, include libraries to that external public.
Exactly, but it's more than a library though. It's more than library. I think traditional library is, of course, is a static library, a piece of code. Whereas here we're talking about a network, right? We're talking about a API of network.
Okay.
which is way more powerful.
So can you describe then perhaps what kind of use cases you see for that? I mean, I can think of some, but I would like to know what types of use cases you envision for this sort of private blockchain also using a public blockchain service.
Yeah, I guess the most common use case I think we talk about a lot is supply chain system. And the weird thing about supply chain system, it involves many different pieces, right? Obviously, in a supply chain system, you probably wanted to use identity. Imagine a semi-open kind of trade financing or supply chain system of a large manufacturer, hundreds and thousands of vendors. Each of them, before they enroll into your system, you might want to do certain identity or reputation check. That database, not database, but that network or public service exists on a public chain. You call into that chain, valid identity. Next step, someone is in your network, you want to do some sort of trade financing, and you would need to move the money around. Well, money exists probably maybe as a stable currency on a blockchain. You probably don't want to use Ether or DFINITY as an underlying token because of volatility. So that's the next thing you want to use. Then, some transaction happens, there's a dispute. Where's my goods? Or there's some quality problems. You probably want to call into a public arbitration system that specializes, for example, in cross-border disputes. We have a network of attorneys, lawyers, arbiters who are providing these services. So you could imagine a chain of these services being called in throughout the life cycle of something like that. And none of that services particularly make sense, I guess, to recreate for internally necessarily.
So that's really interesting in how I like that approach. I think that currently a lot of companies and startups building blockchain infrastructure are sort of torn between, do I need a private blockchain? Do I need a public blockchain?
Yeah.
We see banks doing POCs on Ethereum, others doing POCs on private blockchains, and there's obviously a lot of value in using a public blockchain. And there's a lot of value in using a private blockchain, and having this this hybrid approach, or this sort of dependent on the other approach, is, I think, as a concept, really powerful. However, from your point of view, it does depend upon those sort of services that you build on DFINITY. I'm not sure if you would build them or if community members would build them, but those services need to have there needs to be some kind of network effect behind them. Like if you have an identity system, it needs to be widely adopted. If you have a stable currency, it needs to be widely adopted for a consortium of, I don't know, like some supply chain consortium around fisheries or something like that to adopt that. How do you plan to get there? How do you plan to, get to some sort of massive adoption around these public services for all of this other, private stuff to be enabled?
Well, I mean, just quickly as well. I mean, to answer the question directly through business partnerships, there's a lot of businesses that would like to use public blockchain, if you want to call it that. So more, think about it more like decentralized computers, but they'd like to use public blockchain facilities, sometimes just to link, business clients who want to have private chains, and other times to, help them build a private chain more cost effectively or faster and make it more powerful by linking it into public systems. So there, it's well known that we're working with Boston Consulting Group, Digital Ventures, for example. And, we speak to a lot of international companies through that, for instance. And so there's a lot of demand for this stuff out there. And, DFINITY isn't just myopically focused on the business space at all by any means, but we, do have, strong links to business and do want to kind of help them build out this ecosystem, right? And, currently, there's, my kind of opinion of bank chains is, banks are very worried about, blockchain, so they're jumping up and down saying we've got blockchain, and, it's not really going to, it'll help them optimize their systems, but it's not the future. The future is to have, the future really rests in the court of open public systems. And, private systems will hang off those. and they'll be able to communicate with each other through these public systems, and also build on public services like, in supply chain we talked about arbitration and identity and stable coins, and maybe there's haulage networks so people can even get goods delivered cheaply. And it's a very interesting business paradigm because as Tom says, in the past, we've always been able to build software by incorporating linking in pre-existing software libraries, and in the future people will be able to sort of build live business ecosystems by building on existing ecosystems as though they were kind of components, so that, for example, there could be this network of truck drivers, right, that will deliver things, and you create some kind of supply chain system, and you're thinking, hey, I'd love to add some functionality to this supply chain system so that I get these goods delivered automatically if that's what the sender wants, right? And now you can just link it into this haulage system on the public network, and that's immensely powerful, and a very, very attractive model for the business community, especially when you're talking about, the kind of like high-end, large companies that would like to leverage, functionality for things like supply chain.
Great. Now, with DFINITY, so what's the business model here when it comes to maybe Streamlabs and or DFINITY? I mean, you guys mentioned that there would be a DFINITY token. So is the idea that, you guys would own maybe some of this token, and then, if the network takes off, the token gains in value, that kind of model? Or are you planning to develop services or applications on top of it? Can you share anything about what directions you guys are going?
Yeah, so I think it's a bit of both. So it's in DFINITY, the foundation there will be a certain early contributor pool. There will be many people, including Streamlabs, will be part of the contributor pool. So there is a certain token recommendation that the foundation will recommend. Say, okay, here's your only contributor pool. In addition to the donors, there will be these pieces. That's part of that. The other main part of the Streamlabs model is to create businesses and commercial service around the edge, right? If you think about the system that we create, a protocol we create are at its core, but there will be a lot of peripheral services around the decentralized protocol. For example, in the DFINITY network, there will be people who need to provide private chain hosting and provisioning. Configurations, there will be certain business partnerships and creating these common services that we talk about, right? So there are a number of these services that I think Streamlabs will specialize in.
Or even more simply, mining, right?
Yeah, mining. Yeah, exactly. I mean, in addition, I think the other interesting thing is, since Streamlabs kind of has lots of expertise in building these lower level network protocols, there's also additional services like Phi. We probably don't have time to cover that today, but there will be additional these kind of common services that we could build. And around Phi, obviously, there will have its own ecosystem. I guess Streamlabs kind of generally think of itself very much as an ecosystem builder. We build open protocols, and we provide services around its edge.
Okay, great. So what's the timeline here? When is DFINITY going to launch?
So, we just recently incorporated a not-for-profit foundation near Zurich, and I think it's the first such foundation to get full tax-exempt status. And, obviously, Streamlabs has been, providing money to get that made, and there have been some founders who put some initial funds in, and but it wants to raise additional funds. But actually, in the first instance, probably there'll just be a kind of like seed funder for the foundation, because it takes a while to scale out operations. And then it may do another funder later on. Once technology has been released and people have had the chance to evaluate things like threshold relay and see how it works out in the wild. But the timeline, it may be that the seed funder actually happens this year, and that this main funder will happen sort of in the spring of next year. But we haven't absolutely decided yet, but I mean, we're not trying to push it as well, like some kind of big. We're kind of slightly alarmed by some of these crowd sales. We're not trying to push it as some big thing. We'd sort of recommend actually that it will be public, obviously, so everyone who's interested has a chance to make donations and get recommended for DFINITYs. But we sort of recommend that in the first instance that only people that are really interested in, for example, running neurons or creating mining identities actually make donations and get in, or actually people that have got interest in building on top of the network. So we expect there'll be some donations coming in from people that wouldn't normally get involved in these kind of things. And so we'd sort of encourage people not to speculate on it. And the seed donations round will probably only raise like 1 million Swiss francs in value, possibly a bit more, but thereabouts. And then once we've got these 3 releases, copper, zinc, tungsten, scheduled at the moment. The copper release will have a kind of threshold relay, very high performance chain consensus protocol hanging off that, and the blockchain nervous system. And the copper prototype will be released before the main donations round, and then that will be followed by zinc, which is interoperability, and tungsten, which is the sort of simplified version of our scaling systems. So yeah, I mean, keep your eyes pinned, and there will be a public announcement and a website and so on, probably in the not too distant future. But the first seed round is going to be capped to $1 million, and all these things. It's hard. It's a very risky investment, and we prefer people just to get in who actually want to participate in the network through thought mining in the blockchain nervous system, or compute mining, or actually building on the network at this stage.
So if people want to get involved in DFINITY and what you guys are building, should they wait until that comes out, or is there something they can do today? You guys are not on the open source yet, right? So for example, contributing code isn't something that's possible at this point.
Well, you can come and work for us, right? And we're, at the moment we're trying to build out. Always, I suppose everyone is, but we're always wanting to work with great engineers, and that can come from anywhere in the stack. I mean, of course, we particularly interested in people who've got low-level systems programming skills, crypto skills, protocol skills. But there's also lots of other components to the system. People who are whizzes in writing smart contracts and interfaces and things like that. So, I'd invite anybody that's interested to contact String Labs, and also the foundation will, be appearing on the web soon, and people could also contact the foundation to get involved, for example, as a kind of like a freelance contributor. And a lot of the reason we haven't, there is actually some of our stuff is live actually. People just don't know what it is. But we're using this thing called BLS threshold signatures, and there's a library out there by a guy in Japan, and we're the reason that all this BLS threshold signature stuff has appeared in it recently. So I mean, we do actually have open source out there. It's just no one knows what's related to us and what's not.
So you guys are open sourcing stuff, but hiding under some guy in Japan.
Yeah, I mean, we're an open source company, right? And we don't believe in patents, and so I mean, it's not actually an intentional thing at all. It's just there's just been so much to do, and just getting it all together. And I think as a project, we'd much rather make sure that we release something that, I mean, the crypto, by the way, other people can use it. It's great, but the that's why we're only doing a kind of seed funder for the foundation now. We'd like people who want to get involved and donate to actually be able to have a fully functioning client with threshold relay that they can actually play with it and see how it performs and create a neuron and things like that. So that we don't want to be in a position of trying to convince people of what we might be able to produce. We just want to show people. So
Cool. Tom and Dominic, thanks so much for coming on. It was great talking with you guys, and it's exciting to hear where the project is going. I think a lot of these new blockchains, new protocols that are coming out are really pushing the boundaries. Are going to be very interesting to see what happens there. And yours is certainly one of them that really seems to be at the very edge of what's possible and what can be done. So thanks so much for your work, and we're thrilled to see where it goes, and hopefully also have you back on at some point. Phi, we mentioned it briefly, but that's a very exciting project as well. So hopefully once DFINITY is launched, we can also look at covering that. So thanks so much, guys.
yeah, thank you very much for having us on. Yeah, it's been great.
And thanks so much for our listeners as well. We are part of the Let's Talk Bitcoin network, so you can find this show and any other shows on letstalkbitcoin.com. And of course, you can download and listen to the show in any podcast application or watch the videos on youtube.com/epicenterbitcoin. Thanks so much, and we look forward to being back next week.